Hi, Joyce.
People for our uniform that we don't use.
I figured too I could also be like, hey, sparkle stuff, it's time to leave. Okay. You guys were supposed to work this weekend on? Yeah, okay, that's good. What part of homework? The first 3 quarters, because we talked about, or actually all of 8.3 is about what?
Volume?
Volume. So we have cross-sectional areas, right? That's where we started. And then we have discs, and then we have washers. True. Are they really that? How similar are they? Let me rephrase that.
They're pretty close, actually.
Yeah. Because at the basis of all of this work that we're doing with integration with finding volumes is the formula to find the volume. You basically need to integrate the cross-sectional areas, right? With the dx and the dy giving the thicknesses that are getting infinitesimally thin as we accumulate, yada, yada, yada. Okay, so we have our cross-sectional slices, and then what was going on as soon as we started, those are our basic formulas, as soon as we started revolving.
We need to kind of do a bunch of fancy stuff.
Is it really that fancy? What are our cross-sectional areas if our slices are circular? Pi r squared, exactly. And it's no big deal as long as our region is flush with the axis of revolution, because then it's going to be solid. We can do a strict top minus bottom, no big deal for our radius. When does it get a little bit more complicated?
With washers.
With washers, and what's going on with washers?
There's a slope to the...
Yeah, there's some sort of, it's not flush with the axis of rotation revolution. So we have some empty space, or as a simple way of thinking about it, can you stick something in and it won't get hurt? You have some sort of hollow area, and the mathematical way of dealing with that is that we need to think about whole minus hollow in the sense of the bigger minus the smaller. And I don't think I actually said this explicitly in class. Gerardo, I think I told you afterwards. Remember in woodshop, if you wanted to form something like this, you would start with the hole and then you would take out the hollow, right?
Yeah.
It's the same idea. So the same thing you do in woodshop, you do in calc. Hey, it applies.
And my dad told me to take woodshop.
I wish I had classes like you did. You have way more options as far as like the arts and not shop. You can still do shops. But besides that.
Oh, I would totally take shop.
Hopefully that's what parents are for. Your dad to teach you. Coming back though. We did an example. We actually did a few examples, didn't we?
Yeah, that was fun. And I actually understood it.
Oh yeah, and we went around all different axes. So I want you guys to go ahead and, we could do another one if we had time, but sadly, let's just leave this one, okay? I did put in the notes at the very end, just to make it super easy and super specific. If you do want some extra, because we went really, really fast. Khan Academy, Patrick JMC, they both have great different lessons that work through what we've been doing, except why am I going to take this part out? Do not worry about the volume of these cylindrical shells. Oh, wait. What do we need to worry about? Yeah. So let's get rid of this because we're in BC, not AB, yeah? Okay. So then moving on. Actually, I'm not going to put up a few more examples either. That was for a year when we ran out of time, and it was like, oh my goodness, this is killing me. There we go. We had covered it right before spring break. It was the last thing in AB, and it was an adventure. Okay. Shell method. Something in for accumulating shells.
Same section or no?
No, same section.
It's fine.
Remember, 8.3 was a beast.
I'm trying to decide. I'm wondering if like maybe this, if I don't take notes, it'll register better.
Okay. Okay, that's not bad. Then you'll go make it up later. Jackie's gone. Poor Jackie, I just noticed. Hi, Jackie.
Jinx. We said it.
Alright, I'm gonna get my cool wooden figure.
Sam's awake too. Wow.
You deserve like a punch. Okay, what's the difference between shells and what we've been doing with cross-sectional areas? Cross-sectional areas, we were taking a slice. This one.
I like it onion.
It's a slice, but a different kind of slice, right? Now, if we were to do this this volume using slices. How would we slice it? Vertically or horizontally?
Horizontal.
Because horizontally would give us a washer, right? And if we were to slice horizontally, then question, would it be dx or dy? Because our slices would go across, right? Imagine this. This would be one solid. We could have the thicknesses be dy going vertically. True? So we'd have our whole integral in terms of y, we'd have our bounds in terms of y, we'd have pi right minus left squared. True? We'd have to do the whole minus hollow, so we'd have to make our axis of revolution in the middle, and we'd have to go right minus left, and then we have to go hollow, right minus left. That would be 2 pi r squared, big R minus pi r squared, little r. Now, what's different about the cylindrical shells? What do you notice about how they're sliced?
They're kind of sliced at a curve.
Okay, they're sliced in circular, like it's a instead of being a representative rectangle, right minus left, top minus bottom, it's actually a representative cylinder. That's one way of thinking about it.
I kind of meant like how at the top it curves out.
Oh, I was not showing you that part. Remember that part's inaccurate? It should be fragmented. It should be segmented. Okay. So then coming back down here, isn't this dx? Right. Those are dx. So what was dy before is now dx. Struggle. Let's talk about this. We still have our region being rotated. Okay. We still have our area between being rotated. But what's rotating now? Struggle. Instead of slicing, which I'm going to show you in a second, instead of having your dx for this particular figure, we're going to have a dy. And the reason is that when we slice, we're accumulating cylinders with thicknesses that we're dealing with. Instead, struggle to pretend that's that. Okay. We're accumulating cylinders. So if you notice with this cylinder, instead of slicing, when you have this three-dimensional figure, it would be a weird one because it actually isn't hitting the region at all. So you kind of have, I don't know, I guess it'd be like a candle holder and like one of those globes that goes down straight through. But instead of slicing perpendicular to the x and having dx, we're actually slicing perpendicular to the y, dy, because the thicknesses of our cylinder are what we need to get infinitesimally thin as we're accumulating these shells. Now, as you look at this shell, question, how would you, just for one of these representative ones, how would you find the volume of this cylindrical shell?
Pi r squared.
If we were doing pi r squared h, that would be area of the base, the entire base accumulated up through. That's not good, right? Because it's not going to be solid, it's going to be just the shell. So instead, we're going to be thinking of 2 pi r h, thinking about circumference, the circumference being accumulated up through, except we still need a thickness. Well, how are we going to deal with that? So you can say our volume is going to equal, our 2 pi can come out, our r is going to, r and h, we're going to have to think about those and figure out what's going on. But then we're going to have the thickness be dy, as we all know. The integrand is going to go ahead and make those thicknesses infinitesimally thin and accumulate them through the region that we need. Now, hold on. If we're dealing with y's, that's what we want. We want 2 pi r h to somehow be demonstrated in our integral. We want dy. Can you guys tell where our y bounds are going to be? At the outermost edges. Why is this different? If we were doing washers, wouldn't we have to go from the axis? Right? Wouldn't we have to go top minus bottom for the big R and top minus bottom for the hollow for the little R? That's interesting. So we're going to have our y1 and our y2. Now, looking at this representative cylindrical shell, what's R? Is that determined by the function? What's R and what's H?
this one? The y value.
R is based off the y value of the. Oh, no, that's not the function. Hold on, did they actually give us a name for this function? P of y? Okay, let's just call them f of x, is that okay? But if we're trying to do it in terms of y, then we're going to go ahead and call it f of y, true? I thought it's not labeled on the picture. So we have our function, we have our f of y, our negative linear function with an unknown intercept at d, I suppose. So the r is determined by the function itself minus the axis of revolution. What is the h determined by? That's what they're trying to show here, a little bricks. What's the h determined by? The r is determined by the height going up to the function itself. What is the h determined by?
The f of y in terms of x.
Is it just the age?
We want f of y in terms of x. Yeah, but how do we put that in our function? I'm going to give you 2 examples for you guys to be able to see this a little bit clearer. Long story short, our r is going to be equivalent to an actual y value, it's just the height, whereas the h is going to need to be found from r right minus left. Does that make sense? Because since we're doing dy, then we're going to go ahead and be thinking right minus left. It still applies, but it applies in a little bit different way than we're used to. Because when we're doing volumes of revolution, solids of revolution, right? Everything was going into the r, the top minus the bottom, the right minus the left. All of it was going into my radius. But now that I'm dealing with cylindrical shells, my reference system is actually kind of switched. In the sense of our radius can be found just by a simple y value if it's oriented or going around the horizontal axis of revolution if we have dy. And similar r's, well, let's try to get one that's vertically, or has a vertical axis of revolution and then be able to look at it that way. Here we go.
2 pi r h, that's the accumulation of all the circumferences?
No, the 2 pi r h isn't. The integral accumulates. Remember? The 2 pi r h is going to be, with the dx or with the dy, is going to be the volume of each of the cylindrical shells. But the integral with the dx or with the dy is going to go ahead and make those infinitesimally thin and accumulate them throughout the region. Kind of? So, whenever now the book shows it with P of y h, I would rather you guys just know the geometry formula behind it all, right? That we're using 2 pi r h instead of pi r squared in order to get our infinitesimally thin surface area of the cylinder, if you want to think of it that way, and the dx or dy makes the volume of that little shell. So instead of writing the P, you guys go ahead and change it to R. The book says P, that's all well and good, let's change it to R. Because the r is dealing with the radius. True. And then as we're looking at each of these figures, one with the horizontal axis of revolution and one with the vertical axis of revolution, please realize that with cylindrical shells, as we kind of looked at with that one, if you were doing discs, it would have been dy. With cylindrical shells, it's going to be dx. Our reference system switches just a little bit. The thickness is no longer perpendicular, it's parallel. The thickness is no longer perpendicular, it's parallel. And thus, a silly way of remembering it, that I totally stole from some other teacher along the line, is you can think of it as perpendicular and para-shell. One.
For shells, it's parallel.
So if I have a horizontal axis of revolution, then my representative rectangle is going to be parallel to that, so it's going to be a dy. If I have a horizontal axis of revolution and I'm slicing, it's going to be perpendicular, it's going to be dx. It's perpendicular para-shell. It's a silly way of remembering as to whether to have dx or dy.
Oh, so it's parallel it's gonna be deep.
And sad as you guys noticed, we need to go ahead and finish discs and shells. No, the shell method tomorrow. But as you also notice, our reference system is going to get like totally out of whack. So please, I heard you guys didn't have it ready for today. So go ahead and get 8-3 totally caught up and still shells. I think we're going to save 8-4 until after break. Sound good?
Yeah. Joyce, if you like this video, leave a like, comment. Leave a like, subscribe, and comment in the description below.
Why do you